Have you ever wondered what exists beyond the familiar stars that fill our night sky? For millennia, humanity has looked up, contemplating what really occupies the vast emptiness of space. This innate curiosity has compelled us to explore, to ask profound questions, and to face mysteries that defy our current comprehension. Venturing into the cosmos is more than a quest for answers. It represents a profound journey into the great unknown. For instance, have you ever considered the puzzle of dark matter and why this invisible substance appears to be so fundamental to the universe's structure? Although space might look vacant, dark matter pervades it, shaping the way galaxies form and interact. This is merely one of countless enigmas awaiting us in the cosmic depths. Consider quasars, celestial bodies that radiate immense energy, some of which trace back to the universe's infancy. The light from something that existed billions of years ago reaching us today is a staggering concept, offering a direct window into the history of the cosmos itself. Then there are the supermassive black holes, some of which are thought to have emerged not long after the Big Bang. What processes unfolded in those initial moments to permit the existence of these colossal, star-consuming entities? The story of the universe's development is filled with such unexpected turns, and each new finding brings us a step closer to understanding our own origins. We also have the cosmic microwave background radiation, a potential echo of events that may have occurred even before the Big Bang, pushing us to ask what the universe was like prior to that cataclysmic beginning. And if that weren't enough, there are the cosmic voids, immense expanses of space nearly devoid of any galaxies. The reasons for their existence and the secrets they might conceal present another layer of mystery. As our exploration continues, we find ourselves accumulating more questions than answers. Each of these puzzles invites us to think not just about the universe, but also about our own place within it. Are we the sole inhabitants of this stellar ocean? This search for understanding is a perpetual one, yet every advance brings us nearer to grasping the reality that envelops us. Through this journey, we don't just solve the riddles of deep space, we also come to know ourselves better. Science offers us the methods to comprehend, but the sheer wonder of it all will always leave us with more to ask. So, I invite you to join us on this expedition as we delve into some of the most captivating mysteries the cosmos has to share. This is a voyage that not only stimulates our intellect, but also ignites our inherent spirit of discovery. What truly occupies the void of the universe? While the cosmos may seem empty, it holds far more than meets the eye. Dark matter, an enigmatic substance that we cannot directly perceive, plays a vital role in its architecture. But how can something unseen exert such a powerful influence on everything around us? The solution is found in its gravitational pull, which acts as an invisible binding agent holding galaxies together and orchestrating the cosmic ballet of stars and planets. Think of a vast meadow of flowers. Your first glance might only reveal the blooms, but closer inspection shows a gentle wind swaying them, guiding their collective motion. In much the same way, dark matter fills enormous regions of space, sculpting the very framework of the universe, all while remaining beyond the reach of our senses. So, how can we be sure dark matter exists if it's completely invisible? Scientists have inferred its presence by studying galaxies and the movement of the stars within them, which rotate so rapidly they would simply fly apart without the extra gravitational grip that dark matter provides. This evidence naturally leads to another compelling question. What is the origin of dark matter? The honest answer is that we still don't have a definitive explanation. Some scientific models propose it is composed of particles that we have not yet managed to identify. You could envision the universe as an intricate puzzle where dark matter represents the crucial missing piece we have long been seeking. As we persist in our cosmic exploration, every fresh discovery inches us closer to finally solving this profound enigma. Now, let's revisit the concept of voids. In our daily experience, a void signifies an absence, but in a cosmic sense, it's a domain brimming with mystery. Even in these regions of the universe that appear desolate, dark matter is still present, quietly influencing the formation of large-scale cosmic structures. This implies that the universe is a place of far greater complexity and wonder than we could ever have anticipated. By examining the function of dark matter, we confront the possibility that it is behind phenomena that we don't yet fully grasp. For example, the distribution of galaxies throughout the cosmos often defies our models. The reason some galaxies are found in dense clusters while others drift alone in the immense expanse may be connected to dark matter, which could be orchestrating their placement and evolution. It is truly remarkable to consider that even in the most isolated corners of the universe, where nothing seems to exist, dark matter is working behind the scenes. Its influence, though subtle, is universal, shaping our entire perception and understanding of the cosmos. This invisible component of reality forces scientists to pose even more fundamental questions about the nature of existence. What other truths lie concealed in the darkness of this vast expanse? As we advance in our mission to decode the universe's secrets, dark matter shines as a beacon that illuminates our way forward. It encourages us to challenge our assumptions and to reconsider our perception of reality, prompting us to ask, what if our current understanding of the cosmos is profoundly incomplete? It is precisely these kinds of questions that fuel our relentless drive to explore beyond what is already known. Dark matter confronts us with a captivating paradox. How can we be certain something exists if it remains entirely invisible? Researchers employ advanced instruments and methods to measure its influence, persistently seeking out signals that would validate its presence. In this quest, they extend an invitation for you to join them on this intellectual journey, and you can imagine playing a part in a breakthrough that could reshape our entire conception of the cosmos. This pursuit of dark matter transcends a simple scientific inquiry. It represents an expedition into uncharted territory. Every fresh finding provides a glimpse into the universe's past, showing us the story of its formation and development. Through this exploration, you also come face to face with the vastness of our own ignorance and the marvels that lie just beyond our current understanding. While dark matter is merely one of countless puzzles in our universe, investigating it is essential for grasping the cosmos in its entirety. As you delve into this enigma, it naturally leads you to ponder what other secrets are concealed in the depths of space. You might ask yourself what other incredible phenomena could be intrinsically linked to this elusive substance. The insatiable nature of human curiosity means that each solution we uncover only gives rise to a new set of questions. Consequently, the investigation presses on, propelling us toward the very edge of what is known. Every insight gained about dark matter moves you nearer to comprehending its cosmic function, while serving as a potent reminder of how much remains to be discovered. While researchers labor to piece together this cosmic puzzle, they are simultaneously unlocking a future brimming with potential. What might the universe unveil to you in the years to come? The solutions are waiting out there, and this grand expedition has only just begun. Among the most captivating marvels of the universe are the incredibly remote objects known as quasars. So, what are they precisely? Picture a celestial body with such luminosity that it can eclipse the light of thousands of entire galaxies. That is a quasar, which is essentially the energetic core of an active galaxy, releasing a staggering quantity of power, and its significance to our comprehension of the cosmos is immense. The key to their importance is found in their ancient origins and the insights they provide into the universe's initial moments following the Big Bang. When you gaze at a quasar, you are not merely observing a faraway star. You are looking directly back in time. Since many of these brilliant sources are located billions of light years from us, their light has journeyed across spacetime from an era when the cosmos was a fundamentally different place. What then can they teach you about cosmic history? Quasars offer an unparalleled vantage point for examining the formation of the first galaxies and the evolution of matter in the infant universe. The existence of quasars from a time when the cosmos was younger than 1 billion years old poses a compelling puzzle. How did they manage to accumulate such immense mass and radiate so much energy in a relatively brief period? A potential explanation points to the vast reservoirs of matter that surrounded them, which would have provided the fuel for their incredibly rapid expansion. This leads to the question of the black holes residing at the hearts of these quasars, which are thought to be supermassive, weighing in at billions of times the mass of our own sun. The mystery deepens when you consider how they could have attained such colossal size so quickly. Furthermore, the light emitted by quasars serves as a tool for probing the behavior of the universe on its grandest scales. Through the analysis of this light, scientists can determine the spatial distribution of galaxies and interstellar gas. Consider the incredible prospect of charting the cosmos using the glow from these remote bodies. Every quasar acts as a cosmic lighthouse, piercing the void and exposing the very framework of the universe. Quasars are also fundamental to comprehending how galaxies evolve over time, as many have been linked to episodes of new star birth. You might wonder how such a potent object can exert influence on its environment. As a quasar radiates energy, it warms the adjacent gas, a process that can either stimulate or inhibit the creation of new stars, and this fine equilibrium is vital for understanding galactic life cycles. The study of quasars has yielded unexpected findings related to dark matter as well. While you cannot observe dark matter directly, its gravitational pull on quasars offers hints about its arrangement throughout the cosmos. What secrets about this invisible matter might be unveiled by using these powerful light sources? Every quasar represents another fragment of the vast cosmic enigma that you are striving to piece together. The immense distances to these quasars also provoke inquiries into the universe's expansion. Observing progressively farther quasars allows you to peer deeper into the past, aiding your comprehension of how the cosmos has transformed over billions of years. How did cosmic expansion impact the creation and growth of these celestial giants? The solutions to this question could fundamentally alter our models of cosmology. Yet, the narrative of quasars is far from complete. With increasingly sophisticated telescopes, astronomers are identifying quasars that challenge our current theories. A number of them exhibit a degree of organization that seems improbable, prompting you to question how such structures could have emerged. It is possible that an underlying order exists beneath the seeming randomness, and discovering it could transform your entire perception of the universe. Additionally, quasars offer data about a pivotal era in cosmic history, when the universe's gas transitioned to being transparent to light. The powerful radiation emanating from quasars might have been a key factor in this transformation. If that is the case, you have to ask what other forces were at play in molding the young cosmos, because each new insight from quasars moves you one step closer to solving its deepest secrets. Through detailed observation, scientists have discerned patterns in how these luminous objects are scattered across the sky. Some quasars appear clustered together, implying relationships that are not yet understood. You can't help but wonder what these associations tell us about the very texture of spacetime. Finding the answers could guide us toward a new paradigm for the fundamental structure of the universe. Finally, The light from quasars is a valuable tool for investigating the chemical evolution of the cosmos. By examining the light after it has passed through clouds of interstellar gas and dust, researchers can pinpoint the specific elements that existed in the early universe. This line of inquiry brings you to a fundamental question. What was the process by which the elements constituting everything you know today came into being? Every quasar you see serves as a signpost, allowing us to map the chemical journey of the cosmos. Far from being mere specks of light, these incredibly distant objects are archives, carrying essential data about the universe's origins and growth. They provide you with a fascinating look into the dawn of time, compelling us to question our current understanding of everything. The more we investigate these enigmatic phenomena, the more our discoveries lead to new inquiries, stoking our drive to comprehend the immense cosmos we inhabit. Among the universe's many surprises, one of the most profound puzzles involves the supermassive black holes from its earliest age. These behemoths emerged soon after the Big Bang, when the cosmos was just a fraction of its current age, which begs the question, how could such massive entities have possibly formed so deep in cosmic history? Unlocking this mystery could completely reshape our theories about how cosmic structures came to be. To grasp the scale of the problem, you first have to picture a supermassive black hole, an object with a mass that is millions or sometimes billions of times that of our Sun. The conventional wisdom is that they grow by consuming matter or by merging with other black holes. But the presence of these giants so early in the timeline of the universe creates a significant paradox for scientists. You have to ask, what kind of environment could have allowed these behemoths to appear in a cosmos that was still so young? Our ideas about how black holes form have changed significantly, as we once believed the process took many millions of years. However, finding these supermassive black holes in the ancient universe implies their growth phase was incredibly rapid, perhaps lasting only a few 100 million years. To explain this accelerated development, some researchers propose that the primordial gas and dust needed for their creation were far more abundant than our models had predicted. Picture a scenario where the conditions were perfect for the birth of exceptionally large stars, which would then collapse to form black holes. This cycle might have happened inside dense gas clouds that condensed quickly after the Big Bang, providing a rich cosmic soup for these early giants to arise. Their survival in an expanding universe is just one part of their story, as their immense size and early appearance are fascinating because they are central to the development of entire galaxies. We've found that many supermassive black holes sit at the very center of galaxies, much like gravitational anchors that help define their structure. This presents a fundamental question. Did the black holes orchestrate the birth of galaxies, or did galaxies simply form around these pre-existing giants? Some astrophysicists theorize that these black holes shaped their environments by unleashing intense winds and radiation, which in turn sculpted gas clouds and controlled the rate of star formation. If this is true, their appearance could signify the very start of the galactic age. The hunt for these primordial supermassive black holes has pushed scientists to look far beyond the visible spectrum. Using advanced telescopes, they can detect other forms of light, including infrared and radio waves, which lets them spot the telltale signs of these giants against the background of the early cosmos. Some of the most ancient black holes detected are situated over 13 billion light-years from us, meaning you are seeing light that began its journey when the universe was just a baby. While looking back in time is thrilling, it also forces us to be critical. How can we be absolutely sure that we're observing a supermassive black hole and not a different phenomenon? The investigation is ongoing, and every new finding seems to generate more questions than answers. Recent studies indicate that these early cosmic monsters might have been far more numerous than we once imagined, which would change our entire view on how the universe's large-scale structures were built. If they were so widespread, you might wonder why they aren't visible today. A leading explanation is that countless of these original black holes have since combined, eventually forming the modern supermassive black holes we observe in the hearts of galaxies. As our exploration of the cosmos presses onward, these early supermassive black holes provide you with a unique portal into the distant past. Scientific progress moves quickly, meaning a puzzle today can easily become a solved problem tomorrow. With technology constantly improving, our capacity to see and comprehend these events is also expanding, pushing us toward the next phase of discovery. The narrative of these ancient giants is, after all, only one small part of a much grander cosmic puzzle we are trying to solve. In our journey through the universe, each solution we find seems to unlock a dozen new questions, and every breakthrough moves us closer to solving the cosmos's greatest riddles. The thirst for knowledge is a fundamental part of our nature. As long as mysteries remain, our quest for answers will propel us forward, fueling our innate drive to explore the unknown. Ultimately, you should remember that every one of us plays a role in this universal narrative. Your fascination with these ancient black holes and other cosmic enigmas forges a connection between you and the immense universe. It serves as a reminder that while we may be tiny against the backdrop of infinite space, it is our curiosity and our relentless pursuit of understanding that truly define our significance. This journey often leads us to data that forces a complete re-evaluation of what we were sure we knew about the cosmos. Among the most captivating cosmic puzzles is the cosmic microwave background, which is the remnant thermal energy, also called relic radiation, that permeates the entire universe. You might be asking what this really signifies and why it holds such significance. These are faint, enigmatic signals originating from the deepest reaches of space, so subtle they evaded detection for a very long time. It's a concept that feels torn from the pages of science fiction, but these signals might just be reverberations from events that took place even before the Big Bang. So, what kind of information could these ancient signals possibly carry? Researchers theorize that the cosmic microwave background holds vital clues about the very first moments of creation, a time when the cosmos was a cauldron of unimaginable energy. The key to perceiving something so ancient lies in our modern technology. We have engineered powerful radio telescopes designed to capture these incredibly faint whispers from the dawn of time. Yet, the situation is far from straightforward, as the character of these signals provokes even more profound inquiries. If they genuinely come from a time preceding the Big Bang, what does that imply about the very event we define as the origin of space and time? It raises the possibility that something even more fundamental exists beyond it. This moment remains veiled in mystery, with science still a long way from providing any certain answers about how these signals were generated or what unknown physical laws they might represent. The cosmic microwave background presents another captivating possibility as well. If these signals are truly echoes from a remote past, they might serve as evidence for a cyclical universe, one that has experienced numerous cycles of expansion and collapse. Such a concept completely upends our conventional understanding of time and space, hinting that the cosmos operates in a way that is vastly different from what you and I imagine. Then there is the potential link between the cosmic microwave background and dark matter. We understand that dark matter, a theoretical substance that is invisible because it doesn't interact with light, is crucial to the universe's large-scale structure. Certain scientists are investigating whether the signals from the relic radiation might correspond to the arrangement of dark matter, potentially giving us a clearer map of how the cosmos is put together. Consider for a second that these signals might not only speak of the past, but could also hold hints about the universe's ultimate destiny. Should we ever manage to decipher their message, we could gain profound insights into how the cosmos is set to change over the coming billions of years. This potential alone unlocks a whole range of thrilling prospects for our understanding. Scientific progress, however, is a gradual process, where each new answer seems to unlock even more questions. Furthermore, these signals compel us to consider dark energy, the baffling force that seems to be speeding up the expansion of the cosmos. It's plausible that an undiscovered link exists between the relic radiation and this perplexing cosmic force, adding yet another layer to an already complex puzzle. This quest for knowledge is a journey marked by surprising turns and incredible findings. As exploration continues, it becomes clearer that each discovery is merely one component of a much grander cosmic puzzle. The cosmic microwave background is a critical piece, but should we finally decode its message, it might fundamentally challenge our most cherished beliefs, just as major scientific breakthroughs have done throughout history. In essence, investigating this radiation is a voyage into uncharted territory. Each forward step not only brings us nearer to solving cosmic mysteries, but also forces us to face the sheer scale of all that is still unknown. This relic radiation serves as a potent reminder that the universe is far more vast and complex than we can perceive, prompting you to ponder our position within it and the questions that still lie unasked. Within this great expanse of uncertainty, each new finding acts as a light, guiding us toward the future. So, the next time you gaze upon the night sky, I want you to remember that the cosmos is brimming with secrets yet to be revealed. The cosmic microwave background is just one of them, but it stands as a thrilling testament that the great adventure of space exploration has barely started. Now, have you ever considered the strange alignment of certain quasars, those incredibly luminous and enigmatic objects scattered across space? For decades, this baffling phenomenon has confounded astronomers. Even though these quasars are separated by billions of light years, they seem to line up in ways that hint at a connection we can't yet explain, perhaps pointing to cosmic structures or forces entirely unknown to us. At their core, quasars are the active centers of extremely remote galaxies, each harboring a supermassive black hole. As interstellar matter gets drawn in, it superheats and radiates a tremendous volume of energy, making these objects the most brilliant beacons in the known universe. The pressing question remains, why would some of them display such an unnatural alignment? And what might this reveal about our fundamental grasp of the cosmos? One of the most captivating characteristics of quasars is their immense age. Many of these celestial objects came into being when the cosmos was in its infancy, providing you with a unique portal through which to view the universe's distant past. However, the arrangement of these quasars presents a truly perplexing puzzle. Astronomers have noted that certain quasars appear to be organized along specific directional lines, suggesting they might be interconnected within a far grander pattern. This raises a fundamental question. What force could be responsible for such an alignment? Could these vast structures be evidence of something that challenges our fundamental understanding of universal laws? One leading hypothesis proposes that this ordering is a visible consequence of dark matter's influence, the enigmatic substance that constitutes the majority of the universe's mass, yet remains invisible to us. But this idea introduces its own paradox. How can a substance you cannot see directly shape the structures you can observe? Dark matter is understood to be the invisible scaffolding that underpins galaxies and other cosmic formations. Yet its precise effect on quasar alignment is still a subject of intense debate. Could we be approaching a revolutionary shift in our cosmic model? Beyond the theory of dark matter, some scientists speculate that unknown quantum forces or even extra dimensions might be involved, hinting that the universe could be vastly more complex than we currently imagine. The chance that hidden connections exist between quasars compels you to reconsider the very fabric of reality and how it affects us, observers situated in our small corner of the cosmos. The study of these quasar patterns opens up a host of fascinating inquiries. Are these formations merely a product of cosmic chance, or do they point to something far more profound? Some researchers propose that they could be relics from a period when the universe was much denser, causing structures to form in a completely different manner. The implications of this for our grasp of cosmic history would be enormous. As we delve deeper into these cosmic puzzles, we are forced to consider what this all means for life here on Earth. If there are undiscovered forces and connections governing the universe, how might that alter your search for life on other worlds? The arrangement of quasars could simply be one small component of a much larger, more intricate picture that is slowly coming into view. Science advances continuously, with each new finding bringing us a step closer to solving the universe's greatest riddles. The alignment of these quasars, however, serves as a powerful reminder of how much remains unknown. It forces you to ask whether you are prepared to accept a reality that is far more mysterious than you ever thought possible. With increasingly powerful technology, astronomers are discovering more quasars and meticulously analyzing their arrangements. We may soon uncover answers to questions that now seem beyond our reach. Yet it seems that every solution we find only gives rise to a new set of questions, a perpetual cycle that fuels the relentless pursuit of scientific knowledge. Ultimately, the enigma of aligned quasars encourages you to contemplate your own place within this vast and mystifying universe. It underscores that, despite our remarkable progress in understanding the cosmos, our journey has only just begun. Who can say what other secrets lie concealed in the depths of space, waiting to be revealed? In the grand tapestry of the universe, certain regions stand out as profound enigmas, known as cosmic supervoids. To understand what they are, picture a volume of space so colossal that if you looked around you would find almost no galaxies at all. These areas appear starkly empty when contrasted with the dense galactic concentrations in other parts of the cosmos, posing a fascinating question. Why are some parts of the universe so devoid of matter? Cosmic supervoids are immense stretches in the fabric of spacetime, some of which measure hundreds of millions of light-years across. Their existence baffles astronomers. In an age where our ability to detect and map distant galaxies is ever improving, the presence of these vast, desolate expanses is a profound mystery. Was the matter that should be there displaced, or did it never form in these regions to begin with? One of the largest known examples is the Boötes void. This supervoid is so immense that if you were positioned at its center, you could look out for a distance of over 600 million light-years and fail to see a single galaxy. Meditating on such a vast and empty expanse naturally leads to another question. What does this imply about our theories of how the universe was formed? The theory of cosmic inflation, which posits that the universe underwent an extraordinary expansion in its earliest moments, provides some potential explanations. However, the very existence of supervoids seems to defy this concept. If the universe began in such a uniform state, how could such massive regions with so little matter have ever been created? The answers are far from simple and often generate more questions than they resolve. It is possible that these voids are a natural consequence of the universe's large-scale structure, or they could be the lingering imprints of cosmic events that are still beyond our comprehension. Additionally, supervoids might be connected to the ongoing mystery of dark matter. This invisible form of matter could theoretically be present within these voids, shaping their structure without being detectable by our instruments. If dark matter does inhabit these empty spaces, it begs the question of why the galaxies we would expect to see are absent. The distribution of supervoids is also deeply intriguing, as their arrangement may hold vital clues about the fundamental nature of cosmic evolution, potentially challenging our current models. As we persist in exploring these cosmic frontiers, each discovery not only brings us closer to understanding the universe's secrets, but also serves as a humble reminder of how much we still have to learn. Cosmic supervoids are not arranged randomly. Instead, they seem to be organized into a discernible pattern across the vast fabric of the cosmos. This observation prompts a deeper inquiry. Are there underlying forces or dynamics that steer the formation of these immense, empty regions? It makes you wonder if the universe possesses a fundamental structure that we are only just beginning to perceive. Another compelling line of thought is how these supervoids influence the galaxies that border them. While the gravitational pull of neighboring galaxies typically dictates the birth of new stars and cosmic structures, these interactions operate differently within a supervoid. How does this unique environment alter the evolutionary path of galaxies situated at the edges of these voids? And could it suggest that we are witnessing a place where physical laws behave in an unfamiliar way? Supervoids also carry significant implications for our grasp of dark energy, the enigmatic force driving the accelerated expansion of the universe. A number of scientists theorize that the existence of such massive voids might be connected to the way this energy is distributed throughout space. You have to ask, could these supervoids serve as signposts pointing toward a more profound aspect of the universe's fundamental nature? As astronomers persist in their exploration of these cryptic expanses, our technology continually improves, enabling us to gaze further into the cosmos than ever before. Increasingly powerful telescopes and more sophisticated observational techniques are providing us with vital clues about what supervoids truly are. Yet each new piece of information seems to open up new lines of inquiry, compelling you to imagine the profound meaning behind uncovering the ultimate truth of these voids. Could we be standing at the threshold of a revolutionary new chapter in our understanding of the universe? What secrets about the cosmos's past and its ultimate destiny might these supervoids hold? When confronting these questions, it's essential to approach them with a sense of open-mindedness and curiosity. Because studying cosmic supervoids is about more than just analyzing empty space. It's an endeavor to comprehend the full complexity of the reality we inhabit. These great cosmic mysteries serve as a potent reminder that, for all of our scientific progress, there is still so much left to discover. This quest for knowledge draws us ever deeper into the unknown, where each forward step holds the potential for a groundbreaking revelation. As you contemplate our immense and fascinating universe, it's worth remembering that supervoids are but one part of a far greater puzzle, and unraveling their secrets may guide us toward entirely new theories and a more complete view of our own place in the cosmos. Now, let's turn to those brilliant, fleeting flashes of light that erupt from the depths of space, often leaving you with more questions than answers. I'm referring to gamma-ray bursts, which are colossal outpourings of energy that originate in the distant corners of the universe. These phenomena are so powerful they can unleash more energy in mere seconds than our own sun will produce over its entire multi-billion-year lifespan. Yet their cause remains one of modern astronomy's great enigmas. Picture a lighthouse beam cutting through the absolute darkness of a cosmic ocean. Every time we detect one of these bursts, a new investigation into the universe's mechanics begins. However, despite decades of dedicated research, the precise origin of these cataclysmic explosions continues to be elusive. Are they the aftermath of merging neutron stars? Or do they represent the final, violent cries of massive stars collapsing into black holes? Numerous theories exist, but definitive answers are still beyond our reach. So, what exactly unfolds during a gamma-ray burst? Within a few seconds, incredibly intense beams of radiation are unleashed, powerful enough to be detected billions of light years from their source. The ability to capture these signals from such staggering distances is a testament to the remarkable sensitivity of our modern telescopes, which allow us to witness these extraordinary cosmic events across the vastness of space. Each gamma-ray burst is a singular occurrence, and scientists have meticulously catalogued hundreds of them, with every event showing its own unique characteristics. Some last for just a few milliseconds, whereas others can continue for several minutes. A central question that propels our exploration of extreme physics is what factors determine the duration and intensity of these spectacular cosmic explosions. One of the most astonishing things about gamma-ray bursts is their intimate connection to black holes. The prevailing theory suggests that some of these events are generated during the creation of a black hole, as a truly massive star exhausts its fuel and dies. But why would the birth of a black hole radiate so much energy as gamma rays? The answer may be found in the powerful jets of matter that are ejected along the star's axis of rotation during its collapse, focusing an immense amount of energy into focused beams. Gamma-ray bursts are far more than a scientific curiosity. They also serve as vital tools that provide information about the expansion of the universe. These bursts can be used as cosmic beacons to measure the distances to incredibly remote objects. However, when we observe a burst from a galaxy billions of light-years away, it raises profound questions about whether we can fully trust the information that has traveled for so long through space and time. Then you have to consider the bursts that seem to have even more mysterious origins, which don't align with any of our established categories. These puzzling phenomena are a constant reminder that space is filled with surprises and countless secrets yet to be uncovered. To deal with these anomalies, scientists have established a worldwide network of telescopes dedicated to tracking and analyzing these events in real time, because it's possible these bursts are signals of cosmic processes that challenge our most fundamental theories of physics. Whenever a gamma-ray burst is identified, a frantic race begins to capture every possible piece of data. To investigate these cosmic events, we employ a range of advanced technologies, from ground-based observatories to spacefaring telescopes. Even with these ever more powerful instruments designed to unravel the universe's secrets, the true nature of these bursts continues to elude us. A compelling idea among some scientists is that a deeper comprehension of gamma-ray bursts could be the key to deciphering the puzzles of dark matter and dark energy. Investigating these cosmic flashes might provide vital hints about the fundamental architecture of the cosmos and how it has changed over time. Yet each discovery we make only leads to more profound questions, continually stoking our desire to explore the unknown. To unravel these cosmic riddles, worldwide cooperation has become absolutely essential, with astronomers across the globe pooling their data and hypotheses. This collaborative approach has reshaped our view of the universe, turning science into a shared human endeavor where every new insight contributes to our collective understanding. It makes you wonder what discoveries lie ahead in our ongoing journey into the depths of space. By continuing our investigation of gamma-ray bursts, we stand to uncover more about the cosmos than we could have ever foreseen. So, when you next hear of a gamma-ray burst, I want you to see it not merely as a brief flicker of light, but as a direct glimpse into the universe's most profound secrets. Every single burst presents a fresh chance for a breakthrough, ensuring that our incredible journey of discovery never truly ends. But what about the regions of the cosmos that our instruments perceive as empty? Yet strangely, they resonate with echoes picked up by our radio telescopes. These are the cosmic voids, immense stretches of the universe with very few galaxies, appearing like desolate islands in the cosmic sea. The puzzle, however, is that these seemingly vacant areas are broadcasting signals that defy our current comprehension of the universe. The central question that has captivated astronomers for years is how a void, which by its very definition lacks significant matter, can generate any signal at all. Deep within these expanses, researchers have found unexpected activity, documenting recurring echoes that sound almost as if these empty domains are communicating. It leaves you asking, what message are they trying to convey? One captivating hypothesis proposes that these signals are merely reflections of the universe's background radiation, offering us a look back at the Big Bang and the dawn of time. Yet, the echoes originating from these voids are distinct. They are more like faint cosmic whispers that force us to reconsider our entire model of the universe's structure, perhaps detecting the residual traces of long-vanished galaxies. Other scientists speculate that these echoes could signify phenomena entirely new to us, such as gravitational waves rippling through spacetime, or even concentrations of dark matter in places we assumed were empty. A significant part of the challenge in decoding these messages is the sheer distance involved. Many of these voids are so remote that their signals travel for billions of years before they reach our telescopes, meaning you are eavesdropping on the distant past. What if these echoes hold the very clues we need to understand the evolution of the universe? Astronomers are actively trying to categorize these signals, hunting for patterns that could reveal their origin. While the echoes often exhibit a certain rhythm, almost like a cosmic pulse, these patterns are frequently elusive, prompting intense debate over whether this is a known natural process or something far more profound. Adding another layer to the enigma is the tantalizing idea that these echoes could be connected to dark energy. If this force is what drives the accelerating expansion of our universe, then perhaps these resonating voids are somehow linked to its manifestation. It's possible these vast, empty spaces are actually transmitting information about the fundamental properties of dark energy itself. The investigation presses on, and every new piece of data moves us a step closer to grasping the true nature of these cosmic voids. As our telescopes persist in capturing their echoes, scientists find themselves more and more captivated by the potential they represent. You have to wonder if these voids might just be the key to unlocking the greatest mysteries of the universe. The deeper we explore these cosmic voids, the more we suspect they are far from being just empty expanses. They might actually be portals to a new comprehension of matter, energy, and the universe's grand design. They challenge you to reflect on what it means to exist in a cosmos that can seem so barren. Yet every echo we detect serves as a potent reminder of how much discovery still lies ahead. What the cosmic voids ultimately teach you is that the universe communicates from every corner, even from those that appear vacant. It could be that these echoes are truly the voices of a bygone era, whispering secrets about the birth and development of everything you know. These profound mysteries confirm that deep space is a domain of endless surprises, where even the greatest emptiness has a story to tell. Have you ever found yourself wondering if there is something more beyond the scope of our own existence? The possibility of a multiverse presents the idea that our universe is merely one among many, each governed by its own distinct physical laws and dimensions. This concept is both captivating and disconcerting, as it forces us to consider realities that could be fundamentally different from everything we know, perhaps with alternate laws of gravity or a different flow of time. For centuries, the question of whether other universes could exist beyond our own has captivated the minds of both scientists and philosophers. Within the immense and enigmatic cosmos, the multiverse theory, a hypothetical collection of all conceivable universes, proposes that our perceived reality is just a tiny piece of a far greater whole. But what led us to even entertain this idea? The answer originates from strange signals found within the cosmic microwave background radiation, whose origins seem to defy our current scientific models. Think about the night sky for a moment. Every star and galaxy you can perceive is part of a universe that feels boundless. Yet, what if I were to tell you that this entire cosmos might just be one bubble floating in a vast ocean of other universes? Certain theories propose that at the very instant of the Big Bang, numerous bubbles of spacetime could have emerged, each inflating into a separate universe with its own unique properties and characteristics. So, what specific signals prompted scientists to seriously investigate the existence of these parallel universes? A key piece of evidence comes from the cosmic microwave background, which is essentially the afterglow of the Big Bang. This ancient light, pervading all of space, exhibits irregularities that some physicists theorize could be evidence of interactions with other universes. It's a compelling thought that these fluctuations might be the residual echoes from collisions with other cosmic domains. And what if I explained that there are specific patterns within this cosmic background that point to something else at play? Anomalies detected in the cosmic microwave background have become the focus of extensive research, with some of these unusual features suggesting the influence of other dimensions or even direct interactions between our universe and others. As we investigate these cosmic voids more deeply, we begin to see that they might be far more than just empty regions. They could be windows into a new comprehension of matter, energy, and the very fabric of the cosmos. This notion that we could be in contact, however indirectly, with alternate realities is truly staggering and opens up a cascade of even more profound questions. While science fiction has thoroughly explored the concept of visiting these other universes in countless stories, the truth is we are still struggling to grasp the fundamental nature of our own reality. Nevertheless, modern physics, through frameworks like string theory, suggests there may be additional dimensions hidden from our perception, positioning the multiverse not as a fantasy, but as a plausible theory that could deepen our understanding of universal laws. The multiverse concept also fundamentally challenges our ideas about origin and destiny. If an infinite number of universes exist, does that imply there are infinite versions of you and me? Could every choice we make splinter off into a new universe where an alternative path was taken? This line of thought is not just intellectually stimulating, it compels us to reevaluate our own identity and the true significance of our decisions. Some scientists have gone so far as to propose that across the multiverse, some universes could be teeming with life, while others possess conditions so harsh that life could never take hold. This perspective prompts us to reflect on the sheer uniqueness of our own existence and appreciate its fragility. If we are simply the outcome of a cosmic roll of the dice, it makes you wonder just how many other forms of life might populate these other realities. Within the field of cosmology, the theory of eternal inflation suggests our universe is in a perpetual state of expansion, ceaselessly generating new universes in an endless cycle. The implications for our perception of time and space are monumental. If the cosmos is continually birthing new space-time bubbles, it may be that we can never grasp the full extent of cosmic reality, challenging our belief that the laws of physics we observe are genuinely universal. Naturally, the idea of the multiverse has also seized the public's imagination, with books and films popularizing the concept and inviting people everywhere to contemplate their position in the cosmos. But it raises the question of how much of this is grounded in science versus how much is pure fiction. Although the boundary can seem indistinct, it's undeniable that these concepts have inspired a new generation of scientists to push the frontiers of human knowledge. As our technology progresses, so do our instruments for observing the cosmos. Increasingly powerful telescopes and more sophisticated detection methods are enabling scientists to study the universe with a level of detail that was previously unthinkable. Could these very advancements eventually lead us to the discovery of other universes? While we remain a long way from any definitive confirmation, the journey toward that understanding is itself an exhilarating adventure. The quest for answers is ongoing, and every new cosmic echo we detect brings us a step closer to comprehending the sheer scale of the universe around us. So, the next time you gaze up at the night sky, it is worth remembering that even in the darkest and most silent corners of space, there could be voices out there, just waiting for us to finally hear them. Our search for the multiverse challenges us to reconsider not just our own existence, but the very part we play within the immense tapestry of the cosmos. If countless other universes do exist, you have to ask what that implies for the importance of our individual lives and the choices we make. Delving into these profound questions is an exploration that calls on us to contemplate our own nature and our ultimate position in the grand scheme of reality. The concept of a multiverse, in the end, stands as one of the most compelling enigmas in modern cosmology. Faint signals we've observed in the cosmic microwave background, when paired with developing theoretical frameworks, hint that our reality could be vastly more intricate than we currently comprehend. It is human curiosity that propels us forward, urging us to find the answers to questions that ultimately define who we are. As our comprehension of the cosmos deepens, we may one day possess the ability to look past the boundaries of our own spacetime, finally discovering whether we are truly alone in this immense and puzzling existence. Among the most awe-inspiring and enigmatic structures ever observed in the universe is the Sloan Great Wall. But what precisely is this cosmic barrier? You should picture an enormous gathering of galaxies woven together into a gigantic network that spans hundreds of millions of light-years across space. This cosmic wall is so staggeringly large that its very existence contests every theory we once had about how galaxies form and are distributed throughout the universe. But how could a structure of such colossal proportions have ever come to be? The explanation is far from straightforward. To date, astronomers have confirmed that the Sloan Great Wall is composed of thousands of individual galaxies, containing an estimated mass equivalent to several million trillion stars. The pressing question, however, is why these galaxies are clustered together in this specific formation. Prevailing theories propose that gravity is the primary architect, drawing galaxies toward regions with higher concentrations of matter. Yet this raises another question. What about the galaxies that appear to drift alone in the void? Why were they not drawn into this immense wall? The Sloan Great Wall also forces us to rethink the timeline of cosmic history. Given that the universe is approximately 13 billion years old, you have to wonder how such a massive structure could materialize in what is a relatively brief cosmic time span. Some scientists theorize that these vast formations might have taken shape within the first billion years following the Big Bang. This, however, introduces a new puzzle. If that is the case, why do we not observe a greater number of such structures scattered throughout the cosmos? One of the most captivating features of the Sloan Great Wall is its intricate web-like shape, which is far from a simple straight line of galaxies. This complexity has significant implications for our understanding of dark matter, the elusive substance we cannot directly see, but whose gravitational effects on visible matter confirm its existence. The Great Wall's presence might suggest that dark matter is not merely a passive ingredient in the universe, but a crucial force that actively sculpts its largest structures. This leads to an even more tantalizing question. If the Great Wall is just one of many such formations, what other wonders might lie concealed in the depths of the universe? When you gaze at the night sky, are you truly seeing the complete picture? Or is there an incredible amount left to be discovered? The Sloan Great Wall serves as a powerful lesson in cosmic humility, reminding us just how much we still have to learn. As research presses on, every new piece of data compels us to reevaluate our established models of the universe. Could there be formations even larger than the Great Wall waiting to be found? Some astronomers are now investigating the possibility of cosmic walls and filaments that extend far beyond the limits of our current observational capacity. If their theories prove correct, we are contemplating a universe far more elaborate than we ever dared to imagine. The Great Wall also impacts our theories about the expansion of the universe. If galaxies are concentrated in these massive superstructures, could it imply that the universe's expansion is not uniform? This idea may force us to reconsider our models of dark energy, the mysterious force that seems to be accelerating cosmic expansion. You have to ask if the large-scale distribution of galaxies could actually influence the rate at which the universe itself expands. As we delve deeper into studying the Sloan Great Wall, we find that each answer we uncover only leads to a host of new questions. For example, what part do the interactions between individual galaxies play in building these massive formations? Events like galactic collisions and mergers can dramatically influence the development of these cosmic walls, which in turn makes you contemplate the ultimate destiny of our own Milky Way galaxy. In this light, the Great Wall is not simply an object for scientific study. It acts as a mirror, reflecting our own unyielding curiosity about the cosmos. It stands as a testament to the fact that, despite our remarkable progress in understanding the universe, mysteries remain that both challenge our intellect and inspire us to keep our eyes on the stars. With every technological breakthrough, we inch closer to unraveling the complexity of the Great Wall and its true role in the universe. Ultimately, the very presence of the Sloan Great Wall invites you to reflect on your own existence within this boundless cosmos. If we are inhabitants of a galaxy that is itself a component of an enormous cosmic wall, what does that say about us? By gaining a deeper understanding of these structures, perhaps we can begin to more fully appreciate our own connection to the universe as a whole. The pursuit of answers to these grand mysteries is the engine that drives us to continue exploring, discovering, and standing in awe of the majesty of deep space. So, as you think about the sheer immensity of the Sloan Great Wall, I encourage you to remember that each of us is a tiny piece of something immeasurably larger. It is our innate human curiosity that has guided us to explore, to discover, and to challenge the unknown. What other secrets does the universe have in store for us? The adventure is only just beginning. Within the vastness of the universe, there are certain discoveries that leave us truly bewildered, challenging everything we thought we understood. One of the most significant of these mysteries is the existence of galaxies that appear to have no dark matter. How is it even possible for galaxies to form in a way that seems to violate the fundamental principles governing cosmic formation and evolution? To grasp this anomaly, you first need to recall what dark matter is. An enigmatic substance that constitutes about 27% of the universe, yet remains entirely invisible and undetectable by conventional means. Even so, we can detect its existence by observing the powerful gravitational pull it has on galaxies and other massive objects in the cosmos. So what are we to make of galaxies that exhibit no evidence of this dark matter? Astronomers have been taken aback to find certain galaxies composed almost entirely of the ordinary matter we can see and measure, such as stars, gas, and dust. This startling possibility forces us to ask whether our fundamental theories of galactic formation might be flawed, a mystery that demands we rethink our entire understanding of the universe's structure. A striking example of this is the galaxy designated NGC 1052-DF2, where scientists were shocked to discover a total mass far below what they had anticipated. The most astonishing finding, however, was its complete absence of dark matter. This single discovery has compelled the scientific community to reevaluate many core concepts about how galaxies are born and develop. If a galaxy like this can form without dark matter, it makes you wonder what other cosmic surprises are waiting to be found. The existence of such galaxies also prompts critical questions regarding the true nature of dark matter itself. If some galaxies can form without it, maybe it isn't the essential ingredient for cosmic structure that we once believed. Is it possible that there are different varieties of dark matter that have so far eluded our detection? Science is moving at an incredible pace, and every new piece of evidence challenges us to reconsider our established models. Furthermore, as astronomers probe deeper into the universe, they continue to find more galaxies that fit this unusual profile, questioning the idea that dark matter is a mandatory component for their formation. Some researchers propose these galaxies might have emerged in cosmic environments where gravity and other forces were more influential than dark matter. This makes you question the broader implications of this finding for our perception of the cosmos. If galaxies don't need dark matter to form, could there be other, yet unknown cosmic processes at work? It's possible the solution to this puzzle is hidden within the interplay between ordinary matter and other cosmic forces we have yet to grasp. However, not every astrophysicist is on board with this emerging viewpoint. A number of experts contend that these findings might simply be the product of inaccuracies in our measurements, or faults in the analytical models being used. Perhaps our current perspective is still clouded, preventing us from seeing the complete reality. As more precise observations are gathered and more advanced technologies come online, we may finally reveal the truth behind these anomalous galaxies. With every fresh discovery, we move a step closer to solving the grand puzzle of the universe. The reality of galaxies without dark matter compels us to look beyond established ideas and encourages the exploration of new theories and paradigms. They may hold the very key to understanding not only galactic origins, but the fundamental essence of dark matter itself. As we persist in our cosmic explorations, maintaining an open mind is crucial, since each new observation offers a fresh chance to learn and broaden our comprehension. While certain answers might prove anticlimactic, this very uncertainty is what fuels our innate human curiosity and propels our relentless search for knowledge. It leads us to ask what other secrets might be concealed within the immense ocean of deep space, as every new telescope and every new study brings us nearer to unraveling the enigmas that envelop us. Exploring the cosmos is a never-ending voyage, filled with marvels that constantly test our understanding. And galaxies devoid of dark matter represent just one of the many questions we still need to resolve. As science forges ahead, we can be certain that countless discoveries still await us, And perhaps in the near future, the answers will illuminate the true nature of the universe and our role in it. The quest for truth is an adventure without end, where each discovery marks the start of a new expedition. Fast radio bursts, known by their acronym FRBS, are among the most captivating phenomena in the cosmos. These baffling blasts of energy last for mere milliseconds, yet their source remains a profound puzzle. Have you ever considered what could be causing these cosmic detonations, why they happen, and, crucially, what they might be telling us about the universe we inhabit? I invite you to join me on this investigation to decode the mystery of fast radio bursts. Since they were first identified in 2007, over 700 of these bursts have been registered. But the majority are so fleeting that they are incredibly difficult to analyze. This means astronomers face the challenge of trying to capture these transient flashes and examine them before they vanish back into the void of space. Yet, it's not just their brevity that is so fascinating. Their sheer intensity is equally staggering, with some bursts powerful enough to be detected from billions of light years away, raising the question of what kind of event could unleash such monumental energy. One of the leading hypotheses posits that fast radio bursts could originate from pulsars, which are incredibly dense, rapidly spinning neutron stars. This explanation, however, doesn't account for every observation, particularly why some bursts repeat while others are one-off events. The wide variation in the frequency and duration of these signals doesn't align perfectly with the pulsar model, prompting scientists to investigate other possibilities. Some have even proposed that these bursts might be linked to the activity of black holes, or could even be the technological signatures of an advanced civilization, making you wonder if we are intercepting messages from intelligent life across the galaxy. Thanks to more powerful instruments, like the Arecibo Observatory and China's FAST telescope, we have been able to identify a greater number of these cosmic bursts. Yet each detection seems to introduce even more questions. This ongoing search for an explanation has left many to speculate about the forces behind these brilliant flashes. While some scientists propose that fast radio bursts could be tied to cosmic cataclysms such as merging neutron stars or supernova explosions, these theories still don't completely capture the full complexity of the phenomenon. One of the most remarkable qualities of fast radio bursts is their capacity to travel across both space and time, carrying an informational signature of their journey by the time they reach Earth. What can this signature reveal about the interstellar medium that a burst has traversed? By examining the properties of these signals, scientists can uncover clues regarding the density and composition of the space separating us from their point of origin, turning each burst into a window that looks back upon events that took place billions of years ago. Determining their origin is a challenge that is not just scientific, but also deeply philosophical, as every new insight gained from these bursts compels us to reevaluate our entire conception of the cosmos. These signals actively challenge our established ideas about physics, and their very existence implies that our knowledge of the universe remains remarkably incomplete. Science is a field in constant motion, and fast radio bursts are a perfect reminder that the solutions to our questions frequently spawn entirely new ones. As our collection of data grows, more intricate theoretical models are being formulated to explain these events. Some researchers now theorize that fast radio bursts might be linked to the assembly of structures in the early universe, which leads you to consider the critical role they may have played in cosmology. Is it possible that they could serve as indicators of the very processes that sculpted the universe into its current form? The link between these bursts and the evolution of the cosmos represents a field of study that holds the promise of unlocking new pathways in our comprehension of space. Beyond just their physical properties, the influence these bursts have on the scientific community and the general public is quite significant. with each discovery igniting curiosity and a sense of awe about the universe. How can it be that such extraordinarily energetic phenomena are occurring in the immense emptiness of space? The quest to find answers also serves to remind us of just how small we are in relation to the universe, inviting you to contemplate our own place within the cosmos and to consider what might exist on a scale far grander than we can currently grasp. As astronomers persist in their explorations, every possibility is still being considered, and the fusion of advanced technology, groundbreaking theories, and an unyielding spirit of curiosity propels us to look far beyond the stars. What further secrets might fast radio bursts disclose to us in the times ahead? The answer could fundamentally reshape our understanding of the universe. These bursts are merely a single component of a much larger cosmic puzzle, and each new finding draws us nearer to grasping the vast and elaborate universe that surrounds us. As we forge ahead in our search for answers, it's important for you to remember that every question is an invitation to explore, to discover, and to be amazed by the mysteries that have yet to be solved. Although the source of these bursts continues to be an enigma, investigating them presents a unique opportunity to learn more about the cosmos, and in doing so, perhaps more about ourselves. What would you say if I were to tell you that there is a vast component of the universe that we are utterly incapable of seeing? This puzzle of the universe's missing matter has been a source of bafflement for astronomers for many decades, as they try to determine where all the matter that science predicts should exist has actually gone. To understand this predicament, you must first recognize that the universe is made up of distinct categories of matter. What is known as baryonic matter, which encompasses stars, planets, and everything else we can observe, constitutes only a tiny fraction of what is truly out there. So what makes up the rest? Astronomers have arrived at the staggering conclusion that the majority of the universe's matter is entirely invisible. This substance is dark matter, which, despite being impossible to see or detect directly, still exerts a gravitational pull on galaxies and other celestial bodies. The perplexing part, however, is that even the baryonic matter we can observe appears to be in shorter supply than our calculations suggest it should be. Can you begin to imagine what this means? It would suggest that a large portion of the very substance that builds the universe is simply lost within the immensity of space. It is a staggering fact that scientists estimate up to 95% of the universe's total mass is composed of dark matter and dark energy. But what is the cause of this shortfall in baryonic matter? One prevailing theory posits that some of this material might have been forcefully expelled from galaxies during episodes of star formation. It's possible that when stars detonate as supernovae, they eject a portion of their constituent matter deep into space. But this still leaves the question of where all that matter ultimately went. Another fascinating possibility is that the unaccounted-for baryonic matter could exist in forms that we have not yet learned how to detect. It might be contained within immense, cold clouds of gas, or perhaps it takes the form of rogue planets that wander the cosmos without orbiting a star. It could even be found in exotic configurations of matter we have not yet conceived of. You have to admit, it's a bewildering thought that entire worlds composed of this lost baryonic matter might exist, completely unknown to us. This is a perplexing idea, but the mystery doesn't end with baryonic matter. Dark energy, which appears to be accelerating the expansion of the universe, also holds a crucial role in this cosmic riddle. While baryonic matter is responsible for creating structures such as galaxies and stars, dark energy seems to dictate the behavior of the universe on the grandest scale. Is it conceivable that this energy is somehow interfering with our attempts to locate the missing baryonic matter? Astronomers have employed a range of methods to try and hunt down this elusive substance. including the study of how light from distant galaxies bends when it passes near massive objects. This effect, known as gravitational lensing, has offered valuable clues about the distribution of dark matter. But when applied to baryonic matter, the results continue to be puzzling. A question constantly reemerges. What would the discovery of this missing baryonic matter truly signify? Uncovering it would grant us a much clearer picture of galactic formation and the universe's developmental timeline. Conversely, if it remains forever elusive, you have to wonder what that implies for our fundamental comprehension of the cosmos. It seems this missing baryonic matter is merely a single component of a far grander enigma. Some theorists even propose a connection between it and other profound cosmic puzzles, including dark energy and black holes. This raises the possibility that these distinct phenomena are simply different expressions of the universe's true nature, a concept that makes the cosmic narrative more intricate with every question you pose. The quest for this unaccounted-for matter compels us to re-examine established ideas about how the universe was formed and how it has evolved. You are forced to confront the likelihood that the cosmos is substantially more intricate and mysterious than you can currently conceive. Perhaps the search is not merely for physical substance, but for answers to fundamental questions about our own existence and our place within this vast expanse. As scientific exploration continues and new technologies for studying the cosmos are created, we will almost certainly gather fresh clues about this elusive matter. The ultimate resolution to this cosmic puzzle, however, remains uncertain. It might be that complete knowledge is unattainable, but it is definite that every new insight brings us a step closer to grasping the universe's central mystery. The enigma of the universe's missing matter serves as a powerful reminder that there is always more to learn. It is an open invitation for you to continue observing the heavens, to persist in asking questions, and to never cease exploring. The cosmos is, after all, a realm overflowing with mysteries, and it is the pursuit of solutions that propels us all forward. So, what awaits us when we finally locate the matter that has so long evaded our grasp? That is a question only time can answer. Have you ever considered why certain areas of the universe appear to be expanding more rapidly than others? This observation confronts us with a captivating puzzle that equally fascinates astronomers and cosmologists. Across the immense scale of the cosmos, where galaxies are generally drifting apart, specific regions exhibit an expansion rate that defies our current expectations, prompting questions that could reshape our understanding of everything. To begin, it's crucial to grasp what the expansion of the universe truly entails. Ever since the Big Bang, the fabric of space itself has been perpetually stretching, causing galaxies to drift away from one another in a kind of massive cosmic ballet. But what does it mean when you observe that some of these galaxies are receding with truly astonishing velocity? And what elements are directing this grand cosmic performance? One of the most compelling theories suggests that dark energy, the enigmatic force that constitutes roughly 70% of the universe, is a primary driver. Yet the precise identity of this dark energy remains elusive. While we understand that it exists and is causing an acceleration of cosmic expansion, its fundamental nature is still a profound mystery. Could it be that this force behaves inconsistently across different cosmic regions, thereby causing this asymmetrical expansion? Another captivating inquiry is whether the uneven distribution of matter throughout the universe is tied to this variance in expansion. Since galaxies are not spread out uniformly, but are instead gathered into clusters and separated by vast voids, you have to ask if these cosmic structures might influence the way space expands in their vicinity. Picture a colossal mass of galaxies functioning like a cosmic magnet, altering the rate of expansion in its immediate surroundings. As scientists peer into the heavens, they identify zones where expansion is proceeding more slowly, alongside others where it is accelerating. If certain regions are indeed expanding faster, could they ultimately detach completely from the rest? This concept implies a cosmos in a state of perpetual transformation, where galaxies grow ever more isolated from one another, a scenario with significant implications for the future of life and the universe itself. Furthermore, the prospect of a variable expansion rate challenges our existing understanding of the laws of physics. Are these principles truly universal, or might they have exceptions in particular cosmic domains? If physics doesn't function identically everywhere, then you may need to fundamentally revise our current cosmological models to account for these discrepancies. Modern telescopes and advanced observational techniques are progressively unveiling more details about these differences in expansion. With every new investigation, scientists accrue data that could finally demystify dark energy and the large-scale structure of the universe. We are standing at the threshold of a discovery that could fundamentally alter your perception of the cosmos. In this evolving landscape, cosmology is an incredibly dynamic and thrilling discipline, where each new finding can unlock a host of new questions. As we gain a better understanding of the asymmetry of cosmic expansion, what new theoretical frameworks will arise? Thanks to technological progress, researchers can probe deeper and with greater precision than ever before, seeking patterns that connect the universe's expansion to other cosmic events, such as supernovae, which could hold the key to understanding dark energy's behavior. The history of the universe is a continuously unfolding story, with each new chapter bringing fresh revelations. Scientists are working tirelessly to decode the cosmic fabric and discern how asymmetric expansion fits into this grand narrative. As you delve deeper into these questions, you are challenged to formulate inquiries whose answers might not be straightforward, pushing us to question everything we thought we knew, and to accept that some aspects of reality may be far stranger than ever imagined. The uneven expansion of the cosmos persists as a captivating enigma, serving as a powerful reminder that, despite our significant progress, vast territories of knowledge remain unexplored. An innate part of our nature is the relentless drive to comprehend what is unknown, and delving into these cosmic puzzles promises to guide us toward new frontiers of understanding. The core question, therefore, extends beyond the cause of this asymmetrical expansion to what its existence reveals about our perception of time, space, and our own position within this grand cosmic scheme. What secrets might the universe unveil from within its limitless depths? When you ask how immense the cosmos truly is, the answer proves to be more thrilling than you could possibly conceive. While our most advanced telescopes have provided us with glimpses of galaxies billions of light-years distant, this visible portion is merely a fraction of the total reality. This naturally leads to the profound question of what exists past the boundaries of our perception. As we peer out into the cosmos, we inevitably confront a limit referred to as the observable universe. This is not a solid wall, but rather a conceptual frontier defined by the maximum distance light has had time to travel to us since the Big Bang. What, then, is situated beyond this cosmic horizon? It's a staggering thought that there could be countless galaxies, stars, and perhaps even forms of life that will forever remain beyond our sight, suggesting a universe far grander than we can currently comprehend. Even as our instruments reveal a seemingly endless sea of cosmic bodies, the truth may be that immense sections of existence lie entirely outside our grasp. One can only wonder what mysteries these inaccessible domains might contain. The universe presents a landscape of infinite marvels, and it is the quest for understanding that compels us to perpetually observe, inquire, and venture further. As we persist in stretching the limits of what we know, what new truths will we uncover? Our great journey of discovery has only just begun. It's also crucial to remember that the observable universe is not a fixed entity. It is in a state of continuous expansion. The light journeying to us from faraway galaxies has its trajectory stretched by the very fabric of space as it expands. This dynamic implies that certain galaxies currently visible to us will eventually recede beyond our view. What becomes of these celestial islands once they cross our observational threshold? Are they lost to us for eternity? Or does their departure signify a deeper cosmic process? Many scientists theorize that an enormous, uncharted cosmos exists just past the edge of our observable reality. Among the most compelling ideas is the concept of a multiverse, a hypothetical reality where countless other universes exist alongside our own, each potentially governed by distinct physical principles. The challenge, of course, is determining if such a fantastic notion could be true and figuring out how we could possibly verify the presence of these parallel worlds. An especially fascinating proposition is the possibility that the universe is truly infinite in scale. This concept immediately gives rise to mind-bending questions. If space stretches on forever, does it imply the existence of an exact duplicate of you somewhere out there? Could there even be an infinite number of your counterparts, each experiencing a different version of your life? The notion of infinity draws us into a complex maze of possibilities that fundamentally tests our grasp of what is real. Yet another complication arises from the nature of light itself. Light from the most remote objects requires billions of years to arrive at our location, meaning that when you look at the distant cosmos, you are effectively looking back in time. This raises a critical question. How can we be certain that our current observations reflect the universe as it is today? It's entirely possible that some of the stars or galaxies we see have long since transformed or ceased to exist, while their ancient light continues its journey toward us. We also must contend with the enigma of the cosmic horizon. This horizon functions as a sort of celestial veil, making it impossible for us to see past a specific distance. But what is the reason for this demarcation? Is its presence purely a result of cosmic expansion and the finite speed of light? Or are there additional, as yet unknown variables shaping what we can and cannot perceive? In their study of the cosmos, astronomers frequently come across baffling phenomena. For instance, observations reveal that distant galaxies are not just receding from us, but are doing so at an ever-increasing speed. This discovery gave birth to the theory of dark energy, an unknown force seemingly driving this accelerated cosmic expansion. A significant question that follows is what influence this dark energy exerts on the regions of the universe that lie beyond our observational reach. Progress in our technological capabilities has empowered scientists to probe parts of the universe that were once completely out of view. Despite this, every breakthrough seems to introduce a fresh set of questions. It makes you wonder whether we are genuinely getting nearer to a complete picture of the cosmos, or if our discoveries are simply unlocking access to an even more profound ocean of enigmas. The puzzle of the observable universe's edge presents a profound challenge, not just for astronomy, but for our very philosophy of being. If there is indeed a reality beyond our ability to perceive it, what are the implications for humanity? Does this vastness suggest we are utterly alone, or could there be other sentient life forms out there, similarly contemplating their own place in the grand scheme of things? While we press onward in our exploration of deep space, it's vital to acknowledge that each solution we uncover inevitably gives rise to new inquiries. This quest for knowledge is a truly unending journey. The puzzles presented by the observable universe might feel immense, but they are also a bottomless well of motivation and wonder that drives us forward. Ultimately, the very concept of a universe existing outside the range of our instruments encourages deep contemplation about our own lives. You and I are threads in an immense and intricate cosmic tapestry. Although our perceptions are inherently constrained, the human yearning to grasp what lies beyond our immediate view continues to be one of our most exciting endeavors. The future discoveries we will make are already out there, waiting among the stars for us to find them. The sheer magnificence of the universe can be seen as a grand theater teeming with surprises and enigmas, with every region seemingly concealing secrets that defy our current comprehension. One of these perplexing mysteries involves hidden gravitational lenses, phenomena with the potential to completely reshape our perspective on the cosmos. This prompts the key questions. What precisely defines a gravitational lens? And, more captivatingly, what can they tell us about the universe we inhabit? To grasp this concept, you must first recognize that gravity is more than a simple force of attraction. It is also an agent of distortion. As light from a far-off galaxy travels near a colossal object, like a black hole or another galaxy, its trajectory is bent. This phenomenon, which we call gravitational lensing, can amplify or even create multiple images of that distant galaxy, offering us a warped view of the cosmos. Doesn't it stretch the imagination to consider that when you gaze into the night sky, you might be seeing several apparitions of the very same galaxy? This entire spectacle is orchestrated by the influence of an object you cannot see. Just pause for a moment to contemplate the sheer scale of these hidden structures and what their existence implies for our comprehension of the universe. Gravitational lenses are invaluable tools that help us investigate celestial objects that would otherwise remain forever beyond our reach. They empower us to pinpoint galaxies billions of light-years away, unveiling not just their form and luminosity, but also vital information regarding their mass and chemical makeup. This allows us to peer deeper into the early universe than ever before. So, how can you be certain that what you're observing is an image warped by a gravitational lens? Astronomers employ a clever technique for this. By carefully examining the light from a remote galaxy, they can spot distinctive patterns of distortion. If the images look elongated or appear in multiple distinct locations, it serves as a definitive sign that a gravitational lens is influencing what you see. Now this leads to the most captivating question of all. What is creating these lenses? What objects are hiding in plain sight? And how do they shape the fabric of the universe? Through the study of these cosmic lenses, scientists have pinpointed supermassive black holes as many of the culprits. However, not every object causing this lensing effect is visible to us, which is where one of cosmology's greatest puzzles begins. There are enormous masses that we are unable to see directly, which points to the existence of a vast quantity of dark matter that has yet to be identified. This elusive substance could hold the key to understanding the very processes of galaxy formation and evolution. The presence of these hidden gravitational lenses also brings up compelling questions about how matter is arranged throughout the cosmos. Could these lenses be pointing us toward enormous reservoirs of matter that we have not yet accounted for? By deconstructing the distorted images, astronomers can calculate the amount of matter present in a particular area of space. This method not only assists in charting the visible matter, but also offers crucial clues about dark matter, which constitutes the bulk of the universe's mass. And what about the universe's largest formations? Gravitational lenses are not only essential for examining individual galaxies, but also for enabling scientists to probe the arrangement of matter on much larger scales, such as in galaxy clusters. These immense clusters frequently function as powerful lenses themselves, bending the light from even more remote galaxies and helping us understand how matter is woven into the vast cosmic web. However, the utility of gravitational lenses extends beyond the hunt for dark matter. They can also aid in probing the expansion of the universe itself. By measuring the distortions in the images of distant galaxies, scientists can collect data on the rate of cosmic expansion and how that rate has shifted over eons. This information is vital for piecing together the history of the cosmos and the forces that might be accelerating its growth. Gravitational lenses also grant us a singular vantage point on cosmic events like gamma-ray bursts. These violent explosions frequently happen in regions where lenses are active, permitting astronomers to analyze the bursts in a much richer, more comprehensive context. Each new observation prompts further inquiry into the secrets these bursts contain and their connection to the lensing phenomenon. As our journey through the cosmos continues, these hidden gravitational lenses are proving to be increasingly potent instruments. They give us the ability to look beyond the visible spectrum, challenging our ideas of what is possible in the universe. Every discovery we make brings us a step closer to resolving fundamental questions about the nature of reality and our place within it. Ultimately, the profound appeal of gravitational lenses is their power to remind us of how little we truly understand about the universe. Each time you look up at the sky, you aren't just seeing stars and galaxies. You are gazing into a cosmos teeming with mysteries and wonders. What other marvels does the universe hold for us as we press on in our search for knowledge? That answer remains an enigma that beckons us to keep exploring. What is the true engine behind the expansion of the universe? Picture yourself adrift in a boundless ocean, encircled by an infinite horizon where every wave appears to retreat farther and farther away. The reason for this cosmic recession might lie in a mystifying phenomenon we call dark energy. This force, accounting for roughly 70% of the universe's total substance, stands as one of the most significant puzzles in modern cosmology. How can it be that a component so dominant in the architecture of the cosmos remains so utterly elusive? To approach the concept of dark energy, you must first think about how we observe the universe. Throughout history, scientific breakthroughs have been remarkable, yet the deeper we venture into the cosmic expanse, the more intricate the questions become. Why are galaxies not just separating from one another, but doing so at an ever-increasing speed? This trend was first identified in the 1990s, when astronomers noticed that the light from distant galaxies was shifted toward the red end of the spectrum, a clear sign of their accelerating recession. But what conceivable force could be responsible for this cosmic acceleration? Some researchers proposed that dark energy functions as a sort of anti-gravity. While gravity pulls matter together, dark energy pushes it apart, causing the universe to expand. But what exactly is dark energy? Currently, scientists have been unable to detect it directly, which makes it a truly captivating scientific mystery. Is it an intrinsic property of space-time itself? Or could it be an entirely new form of energy that we have yet to comprehend? This search for answers has left many experts pondering a fundamental challenge. How can you possibly study something that you cannot see? Since direct observation of dark energy isn't possible, scientists have resorted to indirect methods, analyzing its influence on the universe's evolution. For instance, by examining the large-scale distribution of galaxies and studying the cosmic microwave background, researchers have tried to measure its impact. Yet, just when you think we're approaching a definitive answer, a host of new questions arises, forcing us to ask if we are even interpreting the data correctly. The entire theory surrounding dark energy prompts profound questions about the ultimate destiny of our cosmos. Will the universe expand forever? Or could there be a point where this expansion halts, or perhaps even reverses itself? You might imagine a future where dark energy grows so dominant that it pushes galaxies apart, leaving stars and planets utterly isolated in an endless void, which would have staggering implications for matter and life as we understand them. The notion that dark energy's strength might fluctuate over time is another subject of intense debate. While some models propose that it is a constant force, others suggest its power could wane or intensify. What would this variability mean for your place in the universe? It's conceivable that in the far future, dark energy could so radically reshape the fabric of the cosmos that it becomes entirely unrecognizable to us. Meanwhile, progress in technology continuously provides new avenues for investigating this enigma. More powerful telescopes and sophisticated methodologies are enabling scientists to peer into the universe at unprecedented scales and depths. With every new piece of information we collect, fresh theories emerge that fundamentally challenge our existing cosmic models. Could you be on the verge of a breakthrough discovery that will permanently alter your perception of reality? The investigation into dark energy is intrinsically tied to the quest to understand dark matter, another of the universe's great puzzles. Is it possible that these two forces are interconnected, weaving a cosmic web that we have yet to map? Entertaining the idea that these hidden influences operate in concert gives us a new lens through which to view our most fundamental questions. And with each discovery, scientists are compelled to revise what we thought we knew. In a universe so immense and cryptic, dark energy stands as a stark reminder of our vast ignorance. Could you be witnessing the dawn of a revolution in cosmic understanding in the coming years? The answers might be closer than you imagine, yet they remain concealed in the deepest shadows of space. Some researchers even speculate that dark energy might hold the key to the very nature of reality itself, possibly as a sign of hidden dimensions or undiscovered laws of physics. Radical proposals, including string theory, offer a fertile ground for these discussions, pushing the boundaries of what you might consider possible. As the scientific community wrestles with the mystery of dark energy, public fascination with it continues to climb. Questions about the cosmos, the nature of time, and your own existence resonate deeply with many people. Perhaps in seeking answers to these cosmic puzzles, you learn as much about yourselves as you do about the universe. Every new insight into dark energy encourages you to contemplate your position within this boundless cosmos. And as you delve deeper into the unknown, uncertainty becomes a vital part of the journey. What truths will the stars and the immense voids between them reveal in the times ahead? The search for answers is ongoing, and through it all, dark energy serves as a constant testament to the captivating and mysterious nature of the universe you inhabit. Fossil galaxies serve as cosmic time capsules, providing an unparalleled window into the earliest stages of the universe's formation. You have to wonder what secrets these relics from a long-lost era can tell us. Picture a galaxy that has remained largely unchanged for billions of years, perfectly preserving a record of how the very first cosmic structures came into being. Their primary significance is that they allow us to study the formation and evolution of younger galaxies, giving astronomers a clearer picture of conditions in the primordial universe. By observing these ancient galaxies, you can explore what the first stars were like and what raw materials were available for their construction, potentially transforming your entire understanding of cosmic history. One of the most compelling things about fossil galaxies is how their characteristics often defy modern models of galactic evolution. This discrepancy poses an intriguing question. Is there a fundamental gap in your knowledge of how galaxies form? Whenever scientists find galaxies that seem to have developed in unexpected ways, it sparks new theories and debates about the evolution of cosmic structures. As researchers delve deeper into these enigmatic systems, each finding brings you a step closer to solving the riddles of the universe's distant past. Some recent discoveries have revealed that certain fossil galaxies appear to have formed their stars at a much slower rate than we once believed. This challenges your perception of time on a cosmic scale. If these formations are so different, could other, entirely unknown types of galaxies still be waiting to be discovered? Fossil galaxies are often located in regions of space that have been relatively undisturbed since their birth, which raises another fascinating question about what unique conditions enabled their preservation. As our telescopes grow more sophisticated, astronomers are hunting for these cosmic treasures, hoping their secrets will help you better grasp the history and evolution of the universe. These ancient structures might even offer vital clues about dark matter, revealing the role this mysterious substance plays in their formation and stability. By analyzing the movements within these galaxies, scientists aim to learn more about the fundamental ways dark matter shapes the development of galaxies across the universe. A particularly curious feature of these fossil galaxies is the environment they inhabit, as many seem to be encompassed by an unusually sparse amount of ordinary matter, which raises a compelling question. What accounts for this scarcity? It's conceivable that these galactic structures are relics from a period when the cosmos operated under entirely different principles. Researchers hope that by examining these unique surroundings, they can achieve a deeper understanding of how matter is distributed throughout the cosmos. As our telescopes become more powerful, new lines of inquiry emerge. Could there be fossil galaxies concealed in the most remote, unlit regions of space? And what other astonishing discoveries are waiting for us in the sheer vastness of the cosmos? Fossil galaxies represent just a single component in a far grander cosmic puzzle, and every new finding moves us one step closer to comprehending the origins of our universe. Cutting-edge technologies, including advanced radio telescopes and X-ray observatories, empower scientists to investigate these galaxies from multiple perspectives, prompting us to consider how our understanding shifts when we observe the same object through different wavelengths of light. Gathering and merging data from these varied telescopic sources can provide a much richer and more detailed tapestry of cosmic history. The narrative of fossil galaxies, however, extends beyond just their formation, leading us to question their ultimate destiny. Over immense spans of time, will they eventually combine with other galaxies, or are they fated to drift in solitude through the immense void of space? The dynamics of the cosmos are often unforgiving, and the long-term survival of these ancient celestial bodies is governed by the very same forces that sculpt the universe itself. As our knowledge of fossil galaxies deepens, it's essential to situate them within the wider story of the cosmos. You might ask what their existence implies for our own, and by untangling how they formed and evolved, we may uncover vital clues about where we came from and where the universe is headed. These fossil galaxies stand as silent witnesses to cosmic history, with each one we find offering a fresh chance to delve into the questions that have captivated humanity for ages. Are we, in fact, the only sentient life in this immense universe, or is there far more to be found among the stars? The quest for knowledge persists, and every breakthrough serves as an invitation to gaze at the heavens with a renewed sense of wonder and curiosity. When you reflect on the significance of fossil galaxies in our comprehension of the cosmos, it's vital to recognize that every new question simply unlocks a doorway to further mysteries. What other concealed truths might be lying in wait for us to find? This is merely the start of a never-ending voyage to the boundaries of space and time, where each fossil galaxy is another piece in the intricate puzzle of our own existence. What truly lies beyond the limits of our current knowledge? This is a question that has fascinated humankind since the dawn of consciousness. During our survey of the enigmas of deep space, we've explored a great number of compelling subjects. But the reality is that each resolution only paves the way for new inquiries. What secrets does the universe still conceal? And what revelations are yet to be made in the boundless darkness of space? The search for answers has brought us to a fascinating intersection where human curiosity confronts the great unknown. Every star you see in the night sky and each galaxy we observe serves as a poignant reminder that our position in the universe is but a tiny fraction of a much larger, more complex picture. How did these immense structures come to be? And do other habitable worlds exist outside our solar system? Science is constantly advancing, yet there remains an immense amount left to uncover. Dark matter, for instance, constitutes a huge portion of the universe, but it remains entirely invisible to us. How can something so widespread also be so profoundly elusive? Scientists are tirelessly working to find the key to this enigmatic substance, which appears to shape gravity and the very fabric of the cosmos. Unlocking its secrets could fundamentally alter our understanding of physics. Quasars, those brilliant beacons from the primordial universe, tell us stories from an era we can only try to envision. What do they show us about the very first moments that followed the Big Bang? Each new insight gained from them compels us to reevaluate what we think we know about space and time. Light from a quasar can travel for billions of years, and upon reaching us, it reveals a snapshot of the cosmos as it was just beginning to take shape. And what are we to make of supermassive black holes, those cosmic behemoths that seem to have materialized from nothing at the dawn of time? Their existence, so early in the universe's history, presents a profound challenge to our models. These questions are far more than simple curiosities. They are essential to understanding how the very first structures in the cosmos came into being. Meanwhile, the cosmic microwave background radiation provides an echo from the distant past, containing potential signals of what occurred even before the Big Bang. Could these ancient waves be the remnants of a universe that existed prior to our own? Every new piece of evidence invites you to meditate on the fundamental nature of time and existence itself. As we investigate the alignment of quasars, we find cosmic patterns that defy our current comprehension. Why do these incredibly distant objects appear to be interlinked across such vast distances? What unseen forces could possibly be orchestrating this cosmic choreography? The universe is a place brimming with surprises and mysteries that are simply waiting to be revealed. We also cannot overlook cosmic supervoids, those enormous regions of space that seem to be almost entirely empty. Why do they exist? And what can they teach us about the large-scale structure of the universe? As we probe deeper into the study of these voids, we start to realize that even the absence of matter has its own unique story to tell. Gamma-ray bursts represent another profound cosmic enigma. What is the source of these unbelievably powerful explosions? Every time one is detected, scientists are thrown into a whirlwind of competing hypotheses, with possibilities ranging from events involving black holes to supernovae, but we still lack definitive answers. What incredible secrets might be concealed within these violent bursts of energy? And of course, The potential existence of a multiverse raises an exceptionally deep question. If other universes are real, what would that mean for our perception of reality as a whole? The notion that our existence might be just one among countless others is both exhilarating and deeply unsettling. The Sloan Great Wall, a colossal structure that defies established principles of galaxy formation, serves as a stark reminder of just how little we truly understand. You have to ask yourself, what could have led to the formation of such a gigantic structure? And what its existence implies for the universe's ongoing evolution? Every single breakthrough in this field brings us a bit closer to comprehending our own place within the grand cosmic tapestry. Then you encounter the perplexing riddle of galaxies that seem to lack dark matter entirely. How can these cosmic islands even exist without what we believed to be one of their most essential building blocks? This discovery compels us to fundamentally re-examine our theories on how galaxies are born and how they mature over time. As we delve into the source of fast radio bursts, you're faced with powerful signals that have traveled across trillions of light years. What kind of cataclysmic cosmic events could possibly generate these enigmatic transmissions? This quest for knowledge leads us to the very edge of the known universe and hints at what might lie beyond. We are also confronted by the enigma of the universe's missing matter, specifically the vast quantities of baryonic matter that appear to have vanished. It seems that each new investigation poses more questions than it resolves. Yet this is how science confidently pushes forward, always searching for concealed truths. The uneven rate of cosmic expansion presents another mystery that demands our consideration, as certain areas of the universe are spreading apart more rapidly than others. You have to wonder why this discrepancy exists and what consequences it holds for our fundamental grasp of cosmic dynamics. Perhaps the most captivating question of all concerns the very limits of the observable universe and what might exist past the horizon we can see. Every time we gaze into the night sky, we are met with the profound possibility that reality is far grander than we can currently conceive, with puzzles like hidden gravitational lenses and dark energy still waiting to be solved. Ultimately, each new finding helps us understand not just the universe, but also ourselves. Because the search for answers is a journey without end. Every question we manage to answer simply unlocks a door to even deeper mysteries. Within this immense cosmos, it is human curiosity that serves as the engine for our progress. So let us continue to explore, to question, and to marvel at the wonders of deep space together. This grand adventure is truly just getting started.